Hello everybody and welcome back to the Programming Project, where today might be a bit of a short episode. I suspect it will be, but tomorrow will probably not be. That's going to be interesting. So what we need to do today is, you'll notice I've added instances here. Instances and server game loop and updates. We needed to add instances for the game loop to really work. That said, they're going to be largely empty without any entities for now, because that is happening in the next episode. So this might be a bit of a short one, and it's going to happen almost exclusively in the server here. And this is the sandbox. Oh my, okay. Let's hang on a moment. I'm confused. Did I not open? I think I opened the sandbox twice. Okay, let's try opening the correct project here. There we go. This is more like it. This is the MMO server. This is not the sandbox. So I guess you got a bit of a preview there. Wonderful. Okay, so inside of the sandbox, we are going to create ourselves a new folder. And actually, I have one too many sandboxes open here. There we go. So let's go ahead and create ourselves a new folder. So we're going to add a folder, and this is going to be in the game code folder. We're going to need two files here. The first one that we're going to need is a game manager, and we're just going to call this game manager.cs. Wonderful. We're not going to do anything with this just yet. We're going to head back over to our server over here, and we're going to go into our initialization function, because we need to do a little bit of work over here. So the first thing that we need to do over here is we need to come down behind this, and where this says GameManager.server equals this commented out, we're going to uncomment that out. Obviously, this is going to cause a problem, because this is not a thing. That's fine. We're also going to add in GameManager.initGame. Excellent. There's one more thing that I want to do before I forget, and that is we're going to need to go down to process CEW message, and when we log in the character here, before we send the message type, we are going to say we'll need to create a fresh instance for this, since they'll be on their own at first. They'll be in an empty instance with no party. Okay, and then we're just going to do game manager dot create instance, which doesn't exist yet, client session. Excellent. And that should be, I think, all that we need to do in the server.cs. Everything else is going to be happening in game manager and in the actual instance code. So let's go ahead and pull open our game manager here, and there are several different things that we are going to need. We're going to first need to make this a public static class. Excellent. And in order for this to work, we're going to have to change quite a lot of our classes here. Like, for example, in UDP, we'll have to change this from an abstract class to a public abstract class. We'll get to that. I'm getting a bit ahead of myself there. So first thing we're going to need here is a region. We're going to need some const fields. And we're going to end region. There we go. We're also going to need a couple of public fields. So region public fields. And then we're going to need a region private fields. And we'll end that region. We're also going to need a couple of methods, but I don't think we need to put this in a region right now. We can come back and do that at a later date, but it's only two methods, and they're kind of in their own regions. And once we flesh that out a little bit more, we'll decide how we want to handle those fields. So the first thing that we're going to do is we're going to implement that init game function that we are calling in the server up here. We're going to do this. Actually, we'll put in the GameManager.server first. So that's a public field. That's going to be a public static server. Now, That automatically added using channelmmoserver.net code. However, this is causing an error because the server is less accessible. So that means that we need to set the server here to a public class server. And that is causing an error because we need to make the UDP base be a public abstract class UDP base. Now we should no longer have any issues with that. Wonderful. And the server tells the game manager when it initializes, I'm the server. The game manager's like, cool, I'll init the game for you. So we need to implement that. And we're going to do that right down here. This is a pretty simple thing that we're going to do. Public static void init game. And then all we're going to do is we're going to basically start up a new thread the same way we did for the server. So task.factory, and note that this automatically added using system.threading.tasks.startNew. And this is going to be an async function. We will need that. I tried to do it without an async function, and then I was like, no, we actually do need this to be async. So we will make this be an async here. We'll just do curly braces like that. I just like to clean this up a little bit. It's not particularly relevant. There we go. It's not, strictly speaking, necessary to do that. But we will do while running. And of course, running doesn't exist. So we'll have to do that. And I'm just wondering why this is... Oh yeah, because it lacks await operators. Right. It will run synchronously right now. It will have an await operator in just a moment. But we will, of course, need ourselves a private field here. And this is going to be... Is this private? No, this is a public, actually. This is a public static bool running equals true. And then let's go ahead and go into our main window, if I recall correctly where this is. Not there. Here. Yes. Okay, so that's when the server is going up. What happens when the server comes down? Like, when do we end that thread? Do we end that thread? Oh yeah, this is freaking out because sessions aren't public. We need to go into the session, and we need to make this a public class session at this point. There we go. You know what? We don't seem to be actually stopping this at any point. That is something we might eventually want to do. Maybe. That said, we could just simply say, if we stop listening, then we could say GameManager.running is also equal to false, so that we stop running the game manager if we ever stop listening. That's something we could do. Okay, so let's go ahead and start implementing this. So the first thing we need to do is update instances. So we're going to need to say for each is going to be a key value pair of type int and instance. Now, of course, instance doesn't exist in instances, which of course doesn't exist. So let's go ahead and make ourselves our instances. This is going to be a private static dictionary. This is going to be a key of an integer and instance as the value. Instances equals, of course, a new dictionary of that type. Wonderful. So, I mean, that tells us what instances is, but we don't know what an instance is. Let's go ahead and make that. So we will do add new item. This will be a class, and we will call this instance.cs. Excellent. So in instance, this is going to be pretty simple. We will make this a public class, because that will be necessary. And we will need to say public int instance ID, and apparently I can't spell public. There we go. Public int instance ID, and that's the only field that we need. I'm not going to do regions for this class because this is, at least right now, super basic, and I suspect it's going to stay that way. We'll see. If we flesh this out further, then we'll come back and do regions. But for now, we'll just need a constructor here. Public instance int ID, and we want to make sure that if we add more fields, initialize I was right the first time. Initialize them in the constructor. Okay, so all we're going to need to do here is instance ID equals ID. Wonderful. So that gets us our constructor. We need two more methods here. Public string getState update. Actually, we'll come back to these. That's all we need for now, is the constructor. So we'll hop back into the game manager here. And let's see, why is this type and identifier are both required for a... Oh, yeah, because this needs to be key value pair in instances. That would help. Wonderful. So all we're going to do here in this loop is pair.value.tick. Excellent. Now, of course, that doesn't exist, so let's hop over to instance and make it exist. This is just going to be public void tick. And we're not going to do anything at all with it right now. We have nothing to do with it because we don't have anything in the instances. We'll come back to that, but we just want that to be automatically called. So now that we've updated our instances, we are next going to send updated instance state to clients in that instance. Now, technically, we could store this inside of the instances, what clients are in the instance. I've kind of come at it from the other direction here, and we are instead storing what instance the client is in inside of the session, which I feel like is a little bit more useful later on so that we can determine that way. It may be useful to have it in both places. If so, we'll implement that. But for now, all we'll need to do is say for int I equals 0, I is less than subscribed sessions dot count, which of course subscribed sessions does not exist, I++. So let's go ahead and make that exist. We'll put that right here. This is going to be a private static list session of subscribed sessions equals new list session. Now I think this is wanting me to capitalize this. Oh, it wants me to make it read-only. Yeah, we can make that read-only. That shouldn't be an issue. In fact, that should be absolutely fine to have that be read-only. We're not really going to do anything other than calling functions within it, so that's fine. So, when we iterate through our list of subscribed sessions, what are we going to do with it? Well, we're going to just send an updated game state to the clients that are currently in that instance. So we're just going to say server.send, and we're going to send a message type. This is going to be a new message type, GMS. That does not exist. That's okay. We'll make that exist in a moment. This is going to be instances, which is of course our dictionary. So we have to look up the dictionary, or the value in question, by the key, which is the ID here. So that's fine. We have that from our subscribed session. So we can do subscribed sessions I, which is the one we're iterating through, dot instance ID, which of course does not exist, dot get state update, which that should actually work. I'm not sure why that's not. Oh, because, of course, we didn't implement that. I said we'd come back to that later. Yeah. That's fine. And we're going to do subscribed sessions I.address is where we're going to send it. Excellent. Now, in theory, we could make a server function for this. And maybe we should, now that I think about it. That might be a little bit cleaner if we do that. So we would just do a public void send game state update, and then that would be something like it would send, well, we'd need to accept in string update, and we would need to accept in IP endpoint. Okay, and then we'd basically copy this into the server, and this just makes it a little bit cleaner so that the server is the only one that is technically sending. we're just going to have it utilize one of these send functions here. And of course, we need to just send update instead, like that. And then this would be sending it to endpoint. Like that. And then in the game manager, we would then instead call server.sendGameStateUpdate. And this would be... Actually, I need to bring this back because I've forgotten all of this. This needs to be just server.sendGameStateUpdate. And we'll open a parenthesis here. This is our string update. And then this is our address. Wonderful. Now, obviously, it's complaining because sessions don't have an instance ID. So we'll hop over here and we will do a public int instance ID. And this is something that the client has no control over. This is just keeping track of what instance the session is in on the server side. Excellent. And then we need to implement getStateUpdate for the instance, which is easy enough. For now, we are just going to make that be something super simple. It's going to be public string getStateUpdate. And of course, we're going to have a lot more complicated things in this, like we need to be communicating what tile set we're on, we need to be communicating the random generator seed, we need to be communicating all of the enemies that are controlled server side, we need to be communicating other players, all of these things would be included in the state update. But for right now, we don't have any of those things, so we're just going to say return string.format, and this is going to be GameState, and then we want right here double curly braces. The reason we want double here is because that's how you escape the curly braces from the string.format, because it uses curly braces when we're putting in our parameter. So this is going to come out as a single curly brace here. So then we do instance ID equals curly brace 0, and that right there, this guy right here, that's why we double curly brace. Then we double curly brace at the end, and we just pass in instance ID. So we're just, for now, telling the client what instance they're in. Now, technically, they're not going to need that information later on. That's completely irrelevant to the client. The only information that they'll be needing is what I talked about before. The entities, the tile set, the seed to generate the map, and all that stuff is what we're going to need to send in the state update, or in the initial state. We won't need to send the seed in all of them, or the tile set. We would just need to, or even all of the entities if they haven't moved or done anything. We would just need to send an update. But that's why we're doing it in this flexible format that we have already created. So that's it for the instance for now. We will be doing much, much more with the instance, but we do need to hop back over into server, or rather into comms enums. Let's go ahead and hop in here, and let's create ourselves this message type. So this is a GMS, this is a game state update, there we go. And this contains header and game state. We'll just exclude what's inside of the game state. And of course, keep in mind that there's a timestamp at the end too. That will be very important, and we will be utilizing that timestamp for latency calculation and compensation later on. But for right now, we can hop back into our server, and we can see that this function is working just fine, or it compiles anyway. We don't technically know that it's working fine, but we do need to do one more thing when we actually process our message where we log them in, and that is GameManager.createInstance. This does not currently exist, so let's make it exist. In the Game Manager, we are going to do a little bit of magic here to have our instance management happen. So this is going to be public static instance. So this is returning an instance. We're not using that right now. We're not using this reference that it returns, but we might want it later on, so I'm having it return the reference. I don't know if we will want it to later on or not, but for now, we'll have it do this. If we never use this, we can return it to a void. It's not a big deal. And then we'll just have this be create instance. And then we're going to pass in params session. So this is going to be an array of sessions values. So the way that we would end up calling this, and of course this isn't going to compile right now, I'll just have it return null temporarily. We will change that in a moment, but I'm just doing that so it compiles so I can show you how this works. This is a really cool feature of C#. I'm a big fan of this one. And we can hop over to the server here, and you can see here it creates an instance and we pass in client session. But say that we want to pass in also client session, or, you know, just random other session. We can do that with a comma, and then we just put in client session. Of course, we're passing in the same variable twice now, but we can just do this forever. We can pass in however many things we want. And I believe we can also pass in an array of sessions. So if we were, I'm going to delete this, so if you're following along, don't do this. But I'm going to do a session array sessions equals new array of session, and we'll have it be, say, 10. And then we should, I believe, be able to just pass in sessions. Yeah. Fantastic. So we can pass in comma-separated parameters if we have particular ones we want to pass in, or we can pass in an array, and that is absolutely fantastic. I love this. So instead of returning null here, we are instead going to create ourselves a new instance. So instance, new instance equals new instance. And then we're just going to return new instance. But we'll do a little bit more black magic here, as I like to call it. It's not strictly speaking black magic. Of course, we're not passing in an ID here, so we'll need one. Let's go ahead and create ourselves an int key. And we'll pass that in. Of course, this is not currently assigned, so it's going to complain about that. But we need to essentially find what the lowest available key value is. So if there is a key value that is, like, say we have instance 0, okay? And people are playing in instance 0, and they finish it, and they leave the instance, and the instance is destroyed. Instance 0 is then removed from the dictionary, and should be re-available, even if there's already another instance 1. It shouldn't then go to instance 2, it should then reuse instance 0. So, for that, we're going to need another variable here, and that's going to be min_key. Excellent. We'll do an if statement here. If instances.count equals 0, so if there are no instances currently in the dictionary, then we're just going to go with key 0. Simple enough. Otherwise, that's not how you spell. Otherwise, we are going to say our min key should be equivalent to instances.keys.min, like that. So that'll just return the minimum value of all of the keys in the dictionary. Excellent. And I believe that automatically uses system.link. Yeah. So if you didn't automatically get using system.link added, you might need that. This is link, right? I'm pretty sure this is from link. Anyway, we now know what the smallest key in the collection is. If that min key is greater than 0, so if it's 1 or higher, then we want to say that our current key equals min key minus 1. Because we know that this is the smallest key in the dictionary, so if this returns 1, then we want our key to be 0 because we know there is no 0. So we'll do that. Otherwise, if our min key is not greater than 0, that is to say, let's see, our min key greater than, hang on a moment. This isn't going to work the way I thought it would. I need to redo this. So the way I had this going before was key would then be equal to instances. There we go. .keys.max plus 1. However, this needs to be checking to see we know that it's not equivalent to 0. So we already know that it's greater than 0, the min key, which is fine. So what we need to check is if our min key is less than... Hang on, I need to think. I was under the impression I had this tackled, but I did not. So if our minimum key... Let's see, we know what our min key is, we know what our max key is. If our min key is greater than 0, then we set it to this. But we need to also make sure... Yeah, I'm thinking through this right now. This might be a little bit. If our min key is greater than 0, and our min key... We need to make sure that our minimum key here... This is absolutely not going to work. This is as not going to work as it could possibly be. I might have to completely rethink how I'm doing this. Okay, so let's go back to the drawing board on this one. We already know that our instance is not... that we have more than one in this, right? So we know that our key is not equal to 0. So if our min key is equivalent to our min key, obviously. I know this isn't making much sense. This is just the way my brain works right now. So we want to, for now, set our key equivalent to instances.keys.max plus 1. Now that's not going to be what we want that to be overall. Now we need to check if our min key is greater than 0 or equal to 0. If our min key is greater than or equal to 0, then we know that there is nothing below this key in the dictionary. So that means that we should use that number minus 1. So we should use key equals min key minus 1. So that part is correct. Otherwise, if our min key is not greater than or equal to 0, which it always will be, that's the problem. But if our min key is 0, that's fine. Yeah, the problem is how do we get to this section? Because our min key will always be greater than or equal to 0. So hypothetical time. Let's say that we have a collection here. Like this. And our collection is 0, 3, 8. Okay, so this sees that there are 3 in the collection. So it goes to this. And then says min key equals instances.keys.min. If min key is greater than or equal to 0, this evaluates as true because this is equal to 0 and gives us a key of -1. So we don't want this to be greater than or equal to 0. We want this to be greater than 0. So this now evaluates as false and says, okay, we should put it at the end because 0 is taken. Yeah, this is actually... I was correct the whole time. I don't even know what I'm thinking anymore, clearly, because I was correct. The way that this is going to work is if we have a collection like this, it will say, okay, min key is greater than 0, or min key is not greater than 0, so we want to put it over here, so it will insert it as 9. But if we then finish up with instance 0 and delete that from the collection, we now have 3, 8, 9, and min key greater than 0 evaluates as true, which means that key is then at 2. And now we don't have a 0 or a 1 but it'll just keep deducting from that smallest number until it hits 0, and then it'll jump up. So it'll keep filling in these keys as they get used in kind of a haphazard way, but it kind of doesn't matter. Okay, so there's our create instance done. I confused myself, but I was right the whole time. And I just needed to work through it to figure out that I was, in fact, right the whole time. So let's go over here, and let's see here, actually over here, and we can see that this is still complaining that we don't have an async, because we have not actually finished a init game yet. So in the while running, we need to, after we have sent our updated instance states to the clients that are in that instance, we need to have it await a task.delay. This is going to be game speed. Of course, game speed is a const that doesn't exist, so we will create it right up here. This is a private const int game speed equals 100, and that is in milliseconds. Now, keep in mind that depending on how long it takes to do this, it will not always be 100 milliseconds in between game updates. It will, in fact, be longer than 100 milliseconds between game updates. I thought about putting a timer in here and timing how long it took this and then deducting that from here. I don't know. We'll see if we run into performance issues with this. It may happen. In fact, it almost certainly will happen. But at the same time, the tick rate can know how long it's been between ticks up to a precision of about 16 milliseconds or so. Yeah, that might be okay. Anyway, that's not relevant to what we're doing right now. Right now, we are going to be sending this game state update to any client that is subscribed to server or to instance tick updates, which is any client that is inside of an instance, which every client after logging into the character will be. Perfect. Now the client, unfortunately, doesn't know what to do with one of these messages. And because the message is currently so empty, I don't really know what to do with it either, but we'll just handle it like this. So case message types dot gs, what did I call that? GSM? I don't even remember. It doesn't exist though, so we need to hop over to the server comms enums GMS. That's what I called it. GMS. And we need to paste that into the comms enums for the client, just like that. Wonderful. So we now have our game state update, and then we need to actually know what to do with it, which is, I'm getting confused again. Wonderful. We need to go into the net manager here, GMS. This is a GMS update message, rather. And what exactly do we want to do with this update? Well, we do want to make sure that we are putting this incorrectly. Let me switch over to remember what I said here. Okay, this is just simply with an update on our instance. And then all we're going to do here is we're going to do another parse GMS message, because this is going to have very, very important information for the game. Excellent. So we now know our GMS message, and we can do a parse here. Private void parse GMS message, and all we're going to take in here is a string content. And all we're going to do here is debug.log received a game state update plus content. So we'll just verify that we are correctly getting into an instance and getting updates about that instance every roughly 100 milliseconds or so. Of course, we're going to have some latency calculations that we're going to have to do, and we're going to be doing those probably up over here or something like that. We know what time the server sent the message at, and we know what time we think it is. So essentially we know what time the what the time differential between our machine and the server is. So that's excellent. And then I want to check to see, are we... Okay, yeah, this is our server time here. So we can calculate our latency from that. Yeah, I realize that this message is invoked by the Unity runtime, but I've never seen this before. This must be in the newest update for Visual Studio that I just installed this morning. Fascinating. So we'll just parse out that message, and I think that's all we need to do in the client. Do we have any syntax errors in the server? Looks like we do not. Okay, now the question is, just how long does it take the encryption handshake? I really need to change that to a different library. Well, that wasn't too bad. We'll log into ASDF here. Okay, we successfully entered the world. We're not seeing any updates, though. Did we not subscribe? We may not be subscribing. Yep, we are not currently subscribing. We did... I don't even know what I'm doing anymore, clearly, because I did not finish the create instance method here. We missed an important part, and that is everything after here. So the first thing we need to do is we need to say instances.add, and we're going to add in the key here and new instance as our instance. Because no wonder it wasn't working, we weren't putting the instance into the list of instances. And then we need to actually set up our sessions that are inside this instance. So for each session s in values, we are going to say s.instanceID equals key. So the session now knows that it's in the instance. And then we're going to say if not s.subscribed to updates, which doesn't yet exist, and we'll make that exist in a moment, then we're going to need to say subscribed sessions.add s, and also s.subscribed to updates equals true. And that's just a public bool in the session here. Public bool subscribed to updates. There we go. Wonderful. Now it should properly work. So we'll run this. I thought I was forgetting something, which was why I talked about syntax errors. We'll prepare to log in. We'll wait on that encryption handshake for approximately 1 trillion years. Maybe I'll just stay awkwardly silent for the entire duration from here on out until the encryption handshakes are done every time. Well, it's done this time, so we'll just log in. And there we go. There's our game state updates. Glorious. You can see they still come in when we have it paused, and they're coming in at roughly the rate of 10 per second. Excellent. That is pretty much ideal. So we will go ahead and terminate that. And it will stop receiving them instantly, obviously, because it stopped sending them. Excellent. So there we go. We are now in an instance, and we are firing up League of Legends again for reasons. I did not want to fire League of Legends. No, thank you. I need to move this button. You know what? We're going to do something like that. If I'm going to accidentally... Yeah, you can go away. If I'm going to accidentally open anything up, I'd rather it be VLC, because that doesn't actually do anything. That just goes like that. Perfect. So, let's hop over to our to-dos. We now have instances existing. There's nothing in them, but they exist. And we have the server game loop. And we are sending out updates. Very nice. That means, of course, that next we are going to do entities as well as client command sending. Actually, I think we'll just do client command sending. And next episode after that would be entities and server command parsing, because until the server parses the command, having entities is kind of pointless. So that's okay. And there we go. We have achieved the goals for this episode. It is a little bit shorter, but that's perfectly fine. Until next time, you can leave your offerings. I almost said operings. I don't know what an offering is, but apparently you can leave them to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and I will see you all next time.